Hi, my name is Samson, and today I'll be talking to you about how to manage your change process using Terraform Cloud and Git. A bit about me: I have like 10 years DevOps experience. I use AWS Cloud and I use Azure Cloud. I'm AWS certified DevOps engineer. I've got some Azure certification DevOps experience. So I just became HashiCorp certified Terraform associate. And I created my first AWS cloud account in 2010, and since then it's been really interesting. And when I'm not typing codes, I am busy changing my son diapers or playing some games with him or feeding him. So let's go into Terraform. And where are we here? So meet Tunde. Tunde is a DevOps engineer, and I need Tunde and Toby to deploy some changes in my infrastructure. So Tunde is going to run his Terraform codes locally, and he's running his Terraform codes locally. Tunde shares his Terraform codes with Toby, but because Tunde has made some changes that Toby does not have, Toby runs the older codes that Tunde gave him. And what that means is that Toby is going to deploy the old changes to the infrastructure. Now, what we have is we have an unwanted change in our infrastructure, and that is not what we want. So when you work locally, or when you don't use like a remote backend or a remote state, it is not very easy for you to track changes in your infrastructure. And especially when you have more than one person running changes in your infrastructure, you will run into problems, right? You have issues like you might lose your state file. Maybe your state file is corrupt, or your developers might check in the wrong code or run the older version of the infrastructure codes and make unwanted changes in your infrastructure, and we don't want that. What I am going to do right now is that I am going to simulate a broken internet connection. Imagine you're writing Terraform code and you need to apply right now in production, and all of a sudden your internet went off. What is going to happen? You would have Terraform trying to release the state log, and because there's no internet connection, Terraform is going to fail. It won't be able to release the state log, and there will be like a lock in place, but it will not be removed. So as you can see on the left hand side, the internet is gone. So let's assume coworker 2 is trying to run a Terraform apply, and we are sharing the same remote state with the same DynamoDB. Let us look at what is going to happen. As you can see, my coworker 2 gets an error message saying that Terraform is trying to acquire a state log, but Terraform can't acquire the state log. So I will be forced to like disable like the state log, but I don't know what happened, like what caused the initial state log issues. Now I need to like force unlock, so I can use my Terraform force unlock, put in the state ID, and also unlock the state file. And as you can see, this is going to unlock the state file. Now I have my state file unlocked. Local runs, when I mean local runs, I mean running Terraform init, Terraform plan, and Terraform apply on your local system. They are not ideal for more than one person. If you are managing your infrastructure and you have more than one person that is supposed to manage that infrastructure, you should not be running Terraform init, Terraform plan, and Terraform apply locally. Ideally, you should be running it through a version control system like Git, and also behind a CI/CD pipeline, or you could use Terraform Cloud. So when you run Terraform locally, you could also use, you could use your S3 backend. I'm sure most of us that use AWS are familiar with the S3 backend and DynamoDB. When you use your S3 backend and your DynamoDB, you are simply storing your state file in your S3 bucket, and you are also locking that same state file with DynamoDB. It has its benefits, right? Because you could share your state file, you could have your logs to prevent race condition. However, it has some other drawbacks. Like, take for example, I have my state file in my S3 bucket, and before when my developer run Terraform init, Terraform plan from their machine, they use the central state file. But the issue I'm going to face is that there is no approval process, there is no review process. It means that anybody can just run Terraform apply and make any unwanted changes to my infrastructure. That is not what we want. And aside that, a developer might be working on the old version of the codes, and they could make unwanted changes even with our central S3 state bucket and our DynamoDB locking. We still have that issue of people merging or people approving wrong changes in our infrastructures, and people working with the old version of the codes, and that is not what we want. So I'm just going to go straight into why we need Terraform Cloud. Terraform Cloud is simple. Is a simple SaaS solution by HashiCorp that allows you to manage your centralized runs, your centralized Terraform approval. So what that means is that if anybody is making changes to your infrastructure, there's a central location where you can approve the changes to your infrastructure before you actually make those changes. So that means you don't have your developers running Terraform init, Terraform plan, or Terraform apply on their local system. They just submit a merge request, and once they submit a merge request, you look at the Terraform plan based on the merge request, and if it's okay with you, you can approve the plan and also approve the apply. If you're not okay with that, you can discard it. Also, you can control who is accessing your state file, and you don't need to store like sensitive information in a central bucket where everybody can see. You can control who have access to the state file, and it is still running Terraform plan, Terraform init, and Terraform apply under the hood. Part of the features of Terraform Cloud is that you can integrate it with your version control system. So if you're using things like Git, GitLab, if you're using things like GitHub, GitLab, Bitbucket, Azure DevOps, you can integrate it. It is simple plug and play. You just sign up on Terraform Cloud, select your version control system. Once you select your version control system, you would just choose your repository that holds your Terraform config files. Once you do that, Terraform is just going to import it and start running the init process, plan process, and the apply process in the background. And also, I talked about Git branching. What I do is that I have like a default master branch for my Terraform approvers. So I only run Terraform apply on the master branch. Now, what I need my developers to do is that if they need to push any changes to the infrastructure, they create a merge request, they create a branch, then once they work on the branch, create a merge request, submit the merge request. Once they submit a merge request, Terraform Cloud is just going to run Terraform plan on that same merge request, and I can see the outputs of the merge request. If it is something I like, I merge it into the default branch, which is my master branch. Once I merge it into the master branch, I can run Terraform apply. So what that means is that all my developers are not making the actual final changes to the infrastructure. There is a gap, right? There's a gap. So they make code changes, push the code changes to the Git, and I have to approve the code changes before they go into production. So it simplifies managing changes in my infrastructure. And also, it is really easy to set up Terraform Cloud. Just go to app.terraform.io, sign up with your email address, choose your organization name, import your Git repo, and set up your variables. And also it is free for smaller teams. They have some paid features, you could check them out also. So right now I'm going to go into a demo on how to sign up for Terraform Cloud and also how to use it to manage your infrastructure. So let's look at this demo. So I'm going to show you a demo on how to actually sign up and set up the Terraform Cloud. So we're going to go to app.terraform.io, create an account on Terraform Cloud. So let me create an account. So I just created an account. on Terraform Cloud, and now the first screen you're going to see is going to ask you like maybe you want to start with a fresh Terraform config, or you want to migrate an existing Terraform state. So I'm going to just start with a fresh one. I don't want to migrate an existing state. So create your organization name. I'm going to name my organization HashiTalks Africa, and you are going to have to put in your email address for your organization. So once I do that, I'm going to create the organization. So create, and yeah, so right now we're going to connect our version control system. I'm going to use GitHub. So I'm going to connect my Git, put in your username and password. So once you connect to your Git, you need to fetch the repository that contains the Terraform config. So I already fetched the repository that contains my Terraform config, and I'm going to create my workspace. And you can look at the advanced features of Terraform config. You can disable automatic triggers, and you can also select which default branch you want Terraform runs to trigger. So I'm just going to leave it as default and apply. So once you do that, you would wait for Terraform Cloud to pull your config from GitHub. So it doesn't take a lot of time. But while we are pulling the config from GitHub, I'm going to show you something else. You can go to your variables. Because I'm using AWS, I need to have my AWS access key and secret key. So I'm going to go to my environment variable, and I'm going to create my access key and my secret key. So I'm going to copy that from my AWS, create the access key, and I'm going to make it sensitive. Once you make it sensitive, it means that you can only write to it. You can't even view the access key, which is also like a form of security. So I'm still waiting for the config. Let me refresh. Yeah, so my config has been added successfully. So I'm going to go back to my my repo, and let's assume I have two developers. The one on the left is going to create the EC2 instance, while the one on the right is going to create an S3 bucket. So this is my code for creating my Nginx web server. So I'm just going to change the name to Nginx, and I'm going to commit it and push it to my Nginx branch on my Git. So let's take a look at what is going to happen. So as you can see, I just push my codes, and right now I would open the merge request page, and I'm going to create a new merge request right now, or a pull request. So I'm going to open a pull request and comment it, create a pull request. Once I create a pull request, Terraform automatically trigger a Terraform plan. So you're going to see right now, create a pull request, and as you can see, my Terraform is going to run Terraform plan as a check to it. So when I click on it, I can see the output of the plan. As you can, this is my Terraform plan. So I mean, if this looks okay, I'll go back to the merge request and approve the merge request. So by the time I approve the merge request, Terraform is going to run a Terraform apply. So let's take a look at what's going to happen. I'm going to run a Terraform. Terraform Cloud is going to run a Terraform apply. And it is going to ask us if we need to approve it because of it requires a manual approval method here. So as you can see, it is about to apply, and yeah, and I could confirm and apply it. So once that is done, you can see I have my Nginx web server running. Now I'm going to go back to the other repository, or rather the other branch. So the other developer needs to create a new bucket. So he's going to work on his own feature branch and create a new bucket and commit and also merge the code to the Git branch. So as you can see, after doing that, I'm going to open a pull request. So once I create a new pull request on Terraform on my GitHub, create a pull request. Terraform Cloud also run a Terraform plan, so it's going to run a Terraform plan. And once I'm okay with the Terraform plan output, I am going to merge the pull request. So once I merge that pull request, Terraform is going to run the plan and ask me for approval. So once I actually approve the Terraform plan, Terraform is going to actually create the S3 bucket for me. One thing about Terraform Cloud again is that if you have a merge request, let's assume a merge request has been approved by another team member, but we don't want to actually approve that merge request. When Terraform plan runs and it wants to run apply in the Terraform Cloud, it's going to ask us for a final approval process. So what that means is that it needs us to approve the plan. So as you can see, when you use Terraform Cloud, you just need to like create your workspace, import your config, and just have your developers work from different branches in your repository. And also, what you could do is that you could disable write access to the master branch. Make sure that before you can write to master branch, there have to be maybe two people approving, or multiple people approving the codes. I mean, you could use like different strategy that you want to use, but for me, this is what I use, and it really makes it easy for me to work with teams. And as you can see, Terraform Cloud really makes it easy, and it's free for smaller teams, and it is really easy for you to get started with Terraform Cloud, and it makes your job very easy and faster. Thanks for that. I don't know if anybody has any question. If you have any question, you could ask me right now. Thanks. Bye.
All righty. Thank you, Samson. Samson is on with us.
Yes, I am.
Say hello.
Yeah.
So if anybody has any questions, feel free to post in chat and I'll just ask Samson live. But we have a couple people who are saying hello, and they admired your broken internet mocking.
It was pretty epic.
No.
It fooled me. I thought we were having like a HashiTalks Africa glitch.
I know. So out of curiosity, which HashiCorp certification did you get?
The certified Terraform associate, and that was last Friday.
Congratulations. That's awesome.
Thanks.
And between AWS and Azure, which is your favorite certification test to take?
Well, I would say AWS. I mean, any day, anytime, AWS. Yeah. I mean, I love Azure also. Like.
Yeah.
Rosemary, way to put Samson on this.
Well, it's different, right? You know, tests are difficult to take, but also, I don't find them enjoyable. So some people enjoy them. It's challenging. So it was a really cool example that you showed of how you would work with Terraform Cloud. It's very unique. So do you find, the comments and the integrations with GitHub something that's useful for your use, or are there improvements that you see that we could make to it?
Yeah. So for integration to GitHub and other Git protocols and some other VCS, the integration is very smooth. However, I think my concern, or maybe my request, hopefully, would be to have like a global variable. I see that some people have asked the question in the Terraform GitHub pages, but if you have like a global variable, so that means we have like an access key and secret key that we could have, and we could rotate it anytime we want, and we have like some other workspace to be able to consume that global access key. I mean, I don't know, but what I would probably do is I would test out Terraform Enterprise. I would try it out, and I would see if it has that features. But Terraform Cloud is really awesome, man. I mean, people should try it out.
Yeah, I'm glad. Did you get a chance to try the Terraform Cloud run triggers yet?
No, I haven't tried that. I just like set up my VCS and just start pushing to my branches, and everything is smooth. Like the basic features are really, really even smooth. And when you now move to like advanced features, then that means it will be way smoother.
Yeah, that's awesome. There's a feature called run triggers in the Terraform Cloud, so you'll be able to trigger one pipeline after another. So there's a source pipeline, etc. And someone mentioned that there's a variables API where you can rotate secrets and do those global variables. So I think there's probably, a couple ways we could do it, and different patterns too.
Yeah, true.
So do you prefer Terraform ODOT or ODOT I see you had ODOT in there. So
yeah, so I've been using ODOT for a very long time. And I love the fact that ODOT is backward compatible, right? So you are not forced to like upgrade your codes. But however, I see like when I start using version 12, I just like the syntax, and I don't have to like do the interpolations every time. It's really make much sense. And also it makes like my runs very faster. So I prefer Terraform 12. The syntax is very crisp and very clean.
Very cool. So have you gone through refactoring all of your code to go
Yeah,
to
it's
0.12?
pretty simple.
Oh, okay.
It's really simple to upgrade. Like you just run your Terraform ODOT 12 upgrade, and it is going to, you can run the checklist and see what Terraform is going to do, and you can run the upgrade tool, and Terraform will try to upgrade some of your config codes. So it is really, 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 really easy.
Awesome. And out of curiosity, how did you get started with Terraform in the first place? Like what was really helpful when you were learning it?
So I took a course on Linux Academy, and I was with Andela then. So I took a course on Linux Academy, and I finished like the course in like a day, within 4 hours. And since then, I have never looked back. Like, I keep on telling people like Terraform is really easy. Like it is extremely easy. And because it uses HCL, the HashiCorp language, it is really easy. So, and for the fact that it abstracts everything about you connecting to your service provider, it does the abstraction and it gives you like a plain HCL interface that you can use to interact with it. So Terraform is really easy, and I started using Terraform actively like around 4 years ago.
Wow. So that's definitely ODOT 11, ODOT 10 maybe? Even before that, right? Yeah.
Yeah, before ODOT 11, yeah.
Wow. Katie, any questions that you see in the chat?
No, Anton did have a comment. He was agreeing with the variables API that you can rotate secrets there, like Samson was saying. But other than that, no questions coming in.
Cool. All right. So we're running a little bit early. Do you think we should resume playback of the continuing sessions, or maybe we chat a little longer?
Tell a joke.
Does anybody have a good joke?
I'm kidding. Honestly, I do not like when people say that to me in pauses, so maybe I shouldn't have said that to you.
I have a terrible, terrible joke, and it's my go-to joke, and it makes absolutely no sense whatsoever. So I can tell it, but it makes no sense.
Let's hear it.
What do you call a spider without legs?
I don't know. I don't know.
A grape. I don't know. I don't know why that's the answer. Or I never understood it fully, but that was the go-to joke that I have.
It's funny because it's so silly, but I approached it in thinking as it was like a riddle. And to me, grape is not the answer if it's a riddle.
Oh, we do have a question in the chat. Hi, Samson. If you want to use Terraform to build an image and push to AWS ECS for each commit on an application repository, how would you do it with this setup?
So, so with this setup, you need to first of all figure out a way to you have to abstract your image creation. So you could be using maybe your Docker file to build you said ECS. So when you use ECS, you're running Docker instances, right? You need to find a way to get your Docker file to build your Docker images and push it to like ECR. You could do that like maybe you could use Terraform, right, to like pick up to build the container. You can use Terraform to like push the container images to like ECR, or you could use like an external to whatever you want to use, but find a way to push the images first of all to Elastic Container Registry. Then once your images are in Elastic Container Registry, you could always use Terraform to create your tax definitions, to create your service, and also use Terraform to update like that same service. You write your codes. Just think of you writing your normal Terraform config files and running it in locally, but this right now you're not running it locally. You are writing the codes and you're pushing it to your GitHub, and Git is going to do the same. Your Terraform Cloud is going to do the same Terraform init, plan, and apply process for you. It's the same way you're going to write it on your local system, but you're pushing into Terraform Cloud and Terraform is managing the process for you. So whatever you're doing that works for you locally, just try and modify it and push it to Git and let Terraform Cloud run the process.
Cool. And I guess it's sort of a secondary part of this, right? Is that if you have a CI framework, let's say Jenkins or something else, right? If you have a CI framework and you were using the CI framework to build an image and push it to the repository, and then, you know, for each commit that someone was making, how does this change when, let's say, you add Terraform Cloud into this? What are the ways that you might use Terraform Cloud in this pipeline, right? So maybe it's for storing, you know, some infrastructure state, separate infrastructure state. But in CI, can you actually work with Terraform Cloud if you have an existing CI framework?
Yeah, if you have an existing CI framework like maybe Jenkins, CycleCI, or whatever you're using, you can still integrate it with your. You can integrate it with Terraform Cloud. You can still make Terraform to manage the process of plan, and approvals, or you could just use Terraform to manage the remote states. So whatever works best for your team. But to be honest with you, I have used CycleCI and I've used some other CI/CD pipelines to actually manage the plan process, approval process, and run plans on merge requests. But it is not as smooth as using Terraform Cloud. And I'm saying this I'm not trying to market Terraform Cloud, and I'm saying it from my own experience that it is not as easy because I've used that, and you should try it out.
Yeah, it's definitely, I can second that, although I'm a little biased. So, alrighty. Well, if there are other questions, feel free to post in the chat. We'll definitely go through and answer them. Apparently, there was a joke by Nick about UDP, but apparently no one understood it, or I don't think everyone got it. And there's actually more. There's some follow-ups as well. So I have Terraform files with the application repository on each commit. CircleCI, there we go, builds. Then Terraform updates the AWS ECS service. If Terraform files are in a separate repository, how can we get it to update the service?
Files with application repository. I don't really understand your question, but what I picked was that if you have your Terraform files in a separate repository, if you have it in a separate repository, you could call it as a module. So when you have your Terraform files externally, call it as a module, then reference like the tags on the Git, call it, and you can, just convert it into a module and call it from your main.tf file or wherever you are running the actual Terraform runs. I don't know if that answers the questions.
Yeah, I think that's a good approach, and I think that answers the question about if the Terraform files are in a separate repository, formulate them as modules, and that's a way that you can self-service those modules. So I think that's a pretty good pattern to do, especially if you're using a CI framework. All right. So if there are any other questions, feel free to post in the chat. Thank you, Samson, for joining us, and thank you for playing back. It was a great demo. I appreciated the breaking of the internet. That was that was the highlight. That and the mask on the Terraform Cloud credentials, so no one can grab your credentials.
Thanks.
Thank you so much.
Hi, Samson. Thank you.